Hello, welcome. Let us start our 8th lesson of statistics. Today we will discuss measures of relative position. We have already talked about measures of central tendency and dispersion, but today we will focus on relative position. And relative position gives us a way to find out how a data point relates to the rest of the data, how it compares to the rest of the data. So it gives us information such as how the value is close to the average, or if it's unusually high or if it's unusually low. These are some of the pieces of information that the measure of relative position can give us that are crucial to understand the data. When you take an exam, your score is obviously important, but so is the grades of the other people and how you compare to those grades. You typically care about how your score, your mark, compares to the overall class. For example, if you had a 70 from 0 to 100, you're probably happy, right? Because it's a good grade. But imagine that you had a 70 when everyone else had a 90. Then you might not be so satisfied. Or imagine that you have the 70 but everybody failed. Then you would be really happy because you would be the only one that had passed the course and with a good grade. So in general, how significant a value is dependent on how it compares to the rest of the data, to the rest of the observed data points. And this is essentially the concept of relative position. In this video, we will try to answer several questions, such as what is this whole idea of the relative position? Let's see this in detail. What are the three quartiles? Why do I say quartile 4 and 3? What does this mean? What is the meaning of the percentile rank method? How to utilize the z-score? And what are the five big numbers in the 5-number summary? And finally, we will see the box plot, which is my favorite measure of relative position, because it's very descriptive and very expressive. And if you're curious about how I'm going to answer all of these questions, stick around until the end of the video. We will cover theory first, and then as a plus at the end of the lecture, we have a small example of Python. The table of contents for today is the following. I will start by the measures of relative position, quantiles, until the box plots. So stick around and let us see first the measures of relative position. While measures of central tendency and dispersion are important, they have the problem that they do not tell us the whole picture. For example, imagine that you want to study the weight of sumo wrestlers around the world. Of course, you can calculate the average weight if you have data about their weights. And it could be, for example, 155 kilos, a little bit above the world average. And this is an important piece of information. This is a measure of central tendency, the mean, that helps us already know a little bit about the weight of sumo wrestlers. But it's also important to analyze the variability of the weight. And for that, you have a measure of dispersion, which is the standard deviation. You can also use variance or the range. And these measures of central tendency and dispersion, they help us to get a better idea, a better picture of what is going on with the data. But sometimes these measures are not enough, and you need to go a step further using measures of relative position. And what are these measures? They are essentially methods or graphs to show where a given value stands in relationship to the other values in the same grouping of the data. There are several measures of relative position, namely the quartiles, the deciles, the percentiles, also a different method, the z-score, the percentile rank number connected to the percentiles, and 5-number summaries. We are going to talk about these metrics, and we will also review perhaps my favorite topic, which is the box plot, an important and useful tool, graphical tool for relative positioning. Quantiles, and this is very important, are numbers, not percentages, nor groups. They are scores that split a set of sorted data into equal parts, into equal groups. Let me give you an example of a quantile. So imagine that you have 20 company stock prices, stock quotations, from, for example, the Portuguese stock market. We can try to divide the data into 5 groups, and first we start by ordering the stock quotations in increasing order. That's always a given. You always have to sort the data. And then you make groups of 4 companies each. And the boundaries of the groups that you have created will give you the quintiles. Because we are talking about 5 quantiles, we call it quintiles. And the first quintile will be 3.43 at the boundary of the first group. The second quintile will be 4.53. The third, 9.45. And the fourth will be located at 19.80. And you might think, but if it's quintile, it's about 5. Why do we have 4 quintiles? Well, it's a convention that quantiles do not include the lowest and the highest boundaries. And this is the same for all quantiles, either if it's a quartile or a decile or a percentile. It never includes the highest and the lowest boundaries. A quartile, which can also be called a 4 quantile, is a statistical term that describes how we divide observations into 4 defined groups or intervals. So quartiles are organized into low quartile, median quartile, and upper quartile. And the data points, the data values, have to be arranged in increasing order so that you can divide the data into 4 sections of 25% of the data points. And to understand the quartile, it is important, it is relevant to understand the median. We have already discussed the median, and the median is a measure of central tendency. That is the intermediate number of the entire set of data that we have. So it divides the data into sets of 50% of data points. And it is a good metric of central tendency, but it says nothing about how the data in either side of the median is spread or dispersed. And that's where quartiles come in. The quartiles measures or tries to represent the spread of the values above and below the median by dividing the distribution into 4 groups of 25% of the data. Importantly, there's the concept of interquartile range, which is the second group and the third group of the quartiles that represents the interquartile range. And by looking at the interquartile range, we can deduce a lot of important information, such as how the data is skewed around the median and how the data is distributed. We also have the concept of percentile, which is again a type of quantile, and it's obtained by subdividing the data into 100 groups. So we need a lot of data, more than 100 data points, to perform this division. And importantly, it's called percentile, but it has nothing to do with percentage. It's always expressed in the same unit as the input scores, as the input values. For example, if you are studying the salaries of people in a certain company, the percentage will be expressed in euros, in the same unit as the values. There is a correspondence between the percentiles and the quartiles. So the 25th percentile corresponds to the first quartile, and the 75th percentile is the third quartile. The 50th percentile is the median, and this is the score below which we have 50% of the data. So a related measure is when you flip the idea of percentile, you get the percentile rank of a score. So you give a number and we give a percentage. related to that number. In that percentage represents the fraction of scores or values in the data that are less than that value. A cool example that I like to give has to do with percentiles and speed limits. So imagine that you're driving your car down the road and you see, oh, there's a speed limit. How do they even set the speed limit? Well, not always, but in most cases they take into consideration the percentiles, and they look at the 85 percentile specifically, or the 90th percentile, it depends, to check the number below which 85 or 90% of the people drive in terms of speed. And they use these numbers, the percentiles, to assess whether the limits that they have in mind are good or bad, and or even to set the speed limit in the first place. So far we have seen measures of relative position that are based on the idea of grouping the data. But what if I want to see how my data point relates to the mean or to the standard deviation? In that case, you can use the z-score. And the z-score measures exactly, with precision, how many standard deviations above or below the mean a data point is. And the formula for calculating the z-score is as follows. You take the mean from the value, and if the score is above the mean, you have a positive z-score. If it's below the mean, you have a negative z-score. And then you divide by the standard deviations to get how many standard deviations above the mean or below the mean a data point is. Importantly, there are many different names to call the z-score. You also call it standard score, z-statistic, normal score, standardized variable, and in some fields such as physics you call it specific names such as pool. But this process of converting a value into a standard score or a z-score, we usually call it standardizing or normalizing the data. Be aware that sometimes normalizing is used to refer to other ratios. So when you hear the word normalize, it doesn't mean that we are necessarily talking about the z-score. Importantly, because we use information about the mean and the standard deviation, you need to carefully select the formulas for the mean and the standard deviation. Either they come from a sample or from a population, as we have seen in previous videos. Have you ever heard about the 5 numbers? If you have dealt with a large dataset, you probably have used this description tool. And it essentially involves 5 numbers. That's why it's called 5-number summary. And it's the smallest observation and the largest observation plus the 3 quartiles of the data. And we usually represent this as numbers, but we usually represent it in a table. The final measure of relative position that we were going to talk about is the box plot. And the box plot is a method for showing different things, like the central tendency, because you can look at it and you see the mean, the median, immediately, and sometimes even the mean. You can look at the boundaries or the quartiles of the box, and you can see how the data is spread and if it's skewed or not. So you can have all this information right away just by looking at the box plot. In English, we have the concept of the box, which is drawn from quartile 1 to quartile 3, with an horizontal line representing the median. Sometimes, as I said, we have an additional character to represent the mean. And we have the concept of the whiskers, the famous moustaches in Portuguese, and they can be defined in many ways. In the most straightforward way, we define them as the boundaries of the dataset. But when we use a more complex method to define the whiskers, we can also represent the outliers. And the outliers are extreme values that differ significantly significantly from the rest of the dataset, and they are plotted as individual points representing values that are extreme, of course, beyond the whiskers of the box plot. Importantly, and perhaps the reason why I really like this this is my favorite measure of relative position, is because box plots are non-parametric. So they give all this information, but they make no assumption on the underlying statistical distribution, how the data is distributed whatsoever. We are now in our example in Python, and essentially we are going to plot a box plot. Not of just one dataset, but of 4 datasets to compare the data that could be in 4 datasets. And the first thing that I'm going to do is I'm going to import the libraries. And the libraries that I'm going to import are the matplotlib and the numpy. And then I set the seed and I create the 4 datasets. I put the data all in a vector called data. And then it's a matter of plotting the data, of plotting the box plot using the function boxplot of matplotlib. Don't forget to use the show function in the end so that you can show the plot. Now it is time to say goodbye. Thank you for watching and see you next video.